Yeah, Assalamualaikum warahmatullahi taala wabarakatuh and very good evening. So today we are from Group 8. We'll present our answer for the SAL assignment which entitled Sequence and Series in Cryptology and Finance. So first and foremost, I will introduce my group mate. First one is Nick Haris Mustaqim bin Nick Maharis. Metric number 207622. Muhammad Shahin Naim bin Alias 208200. Muhammad Nabil bin Helmi 207613. Fatimah Rukayah binti Hassan 208071. Muhammad Firdaus bin Kamarul Arifin 208103. So I will explain about the task 1 and task 2 first. Right. So, okay, for task 1, find the sum of arithmetic series in 1, which is this an equal to a1 plus n minus 1d, denoted by sn. So, firstly, we need to expand the series, which is sn equal to uh, a plus d plus a plus 2d plus a plus n minus 2d plus a plus n minus 1d. And for the second one, we do the same as the first equation. I mean the first series, but we interchange it from the back side uh, to the forward, from back to forward. So a plus n minus 1d plus a plus n minus 2d plus plus a plus 2d plus a plus d plus a. So for the next uh, for the next step, we need to add uh, the first series with the second series. So how we can do that? Alright, wait. Okay, so basically we will add this one, the first term. Okay, so the first term of the first series with the first term of the second series, which is a plus uh, a plus n minus 1d. So you will get 2a plus n minus 1d, and it will repeated for the next for the next term also, and this one, and for the next also. So it will get the same value, which is 2a plus n minus 1d 2a plus n minus 1d until the end of the series. So we get 2sn equal to n bracket of 2a plus n minus 1d. Then we bring these two into the right side. So it will become n over 2 bracket of 2a plus n minus 1d. So that's the answer for the task 1, which is the sum of arithmetic series. Alright, for the task 2, consider the sum of the arithmetic series obtained in task 1 as the encryption equation. So let's alphabet. A equal to 1, B equal to 2, C equal to 3, and so on until Z equal to 26. To be A or the plain text, while D equal to 14 and N equal to 3 are the keys of this encryption equation. Suppose the resultant of the equation to be the ciphertext value. Complete the table given below that shows the plain text and its corresponding value with the ciphertext and its corresponding value. So I will show the plain text first. So the plain text is A, B, C, D, E, F, and the plain text value is 1, 2, 3, 4, 5, 6, and so on. Right. Okay, so this is the equation that we get the sum of the arithmetic series from the task 1, which is Sn equal to n over 2 bracket of 2a plus n minus 1d. So Sn is considered as ciphertext value and A is considered as plaintext value, where n equal to 3 and d equal to 14. Alright, so I will do for the A first. Okay, so Sn equal to, okay, so n over 2. So n I will substitute with 3. So 3 over 2 and 2a. A I will substitute with 1 and plus 3 minus 1, which is n, and substitute with 3, 3 minus 1, and d is 14. So substitute with 14. So we'll get the answer 45. And for the b, so Sn equal to 3 over 2, 2 multiply with 2 because b, the plain text value for b is 2, and 3 minus 1 multiply with 14, and we will get the answer 48. And we will do the same step until z equal to 26. As we can see, the difference between B and A is 3. Like we can see 48 minus 45 is 3. So as we can see here for the table, okay, so as we know A, B, C, D, E, F, G until Z. So the plain text is 1 until 26. And we can see like the first one we did is was 45. Then second one the 48, and we plus 3 we get 51, and we do and that so on until we get Z equal to 120. All right. So after that, we need to get the ciphertext from the ASC2 table. Right. So I get this 45 is equal to dash. Alright, so 48 is equal to 0, 51 equal to 3, 54 equal to 6, 57 equal to 9, uh, 60 equal to sign of less than, 63 equal to question mark, 66 equal to capital letter B, 69 capital letter E, 72 capital letter H, 75 capital letter K, 78 capital letter N, 81 capital letter of Q, and 84 capital letter of T, 87 capital letter of W, 90 capital letter of Z, and 93 is close bracket, 96 is apostrophe, 99 is small letter of C, 102 small letter of F, 105 small letter of I, 108 small letter of L, 111 is equal to small letter of O, 114 is equal to small letter of R, 117 is equal to small letter of U, and the last one, 120 is equal to small letter of X. So the task us to find the using the completed table, encrypt the text below, which is mathematics is fun. So based on the ciphertext sign that we get, which is from ASC2 table, so we can compute that mathematics is fine. We can get from Q, M is equal to Q, Q capital letter, A equal to dash, T equal to F, small letter of F, H equal to capital letter of B, E equal to 9, M equal to capital letter of Q, A equal to dash, T equal to small letter of F, I equal to E, capital letter of E, C equal to 3, S equal to small letter of C, I equal to capital letter of E, S equal to small letter of C, F equal to the sign of less than, and U equal to small letter of I, and the last one N equal to capital letter of T. Right, so that's all from me. Then I will pass to my group mates for the explanation of task 3.
Right. So I am going to present for task 3, which includes two sub question, which is task 3A and then task 3B. So task 3A requires building the decryption function based on function in task 2. So Shaheen just now have showed us the encryption function. And from that encryption function, we can actually create a decryption function which acts as a decryptor in order to find out what a decrypted text says. So if we see to the left, we will see that Sn equals to n over 2 in bracket 2a plus n minus 1d. N is 3 and d is 14 is the same as in task 2 and task 1. The problem here that we need to solve is to create a decryption function from that encryption function. So as you can see, I put the value of n and the value of d inside the encryption function and then solve it, and then I get the equation Sn equals to 3a plus 21n minus 21. I bring uh, all of the variable except 3a to the left, and then I am left with Sn minus 42 equals to 3a. The reason why I did this is because the value of a is the plain text value. Since the encryption function uses the ciphertext value, if we want to make it into a decryption function, we need to put a as the subject, so that we can find the plain text value of our chosen ciphertext value. So to use the decryption function, we will first identify what ciphertext that we want to decrypt based on the ASCII table. Then using the ASCII table, we can find the ciphertext value for the ciphertext that we want to decipher. We then substitute the value into Sn of the decryption function, and then that gives us the value of a, which is the value of the plain text. And after that, we just need to find the value of the plain text that corresponds to the plain text itself, and that plain text is the alphabet that we want to decrypt. So as you can see, a equals to Sn minus 42 over 3 is the decryption function uh, of this task. And then we will go to the next task, which is task 3b, which is to decrypt the text that is shown in the screen. Question mark WW6 HW0 UWI6E6EF. In order to decrypt it, we need to use the decryption function found in task 3a just now and follow the steps that were mentioned. For example, if you want to decrypt the question mark, we will take a look at the ASCII table, and then we find out that the ciphertext value for the question mark is 63. Now, we take that 63 and then we put it into the decryption function that we did just now, which is a equals to Sn minus 42 over 3, which will give us the value of plain text 7. And if we go back to the ASCII table, we will see that the plain text value 7 means that it corresponds to the letter G. We will just follow this process over and over again for each letter. And then after we have done the calculation process for each ciphertext, we will get that um, question mark WW6 HW0 UWI6E6EF translates to good job, you did it. And that is basically it for task 3. Now I'm going to hand it over to my other group mate for the next question.
So I am going to presenting for the task 4. So for the task 4, find the sum of the geometric sequence in 2 denoted by Sn. So Sn is equal to A plus AR plus AR power 2 plus dot 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 plus AR power n minus 1. Just add the terms given. So then next we have to multiply both sides by r. So we got that RSN is equal to AR plus AR power plus AR square plus AR power 3 plus dot 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 plus AR power n. And next we have to subtract the equations above. Sn minus Rsn is equal to A minus AR power n. And then we have to factor R, Sn, and A. And then we got that Sn bracket 1 minus R equal to A1 minus R power n. So the last step is we have to divide both sides by 1 minus R. And then we will got the answer. Sn is equal to A multiply with 1 minus R power n divide with 1 minus R. This shows that Sn is equal to A multiplied with 1 minus R power n over 1 minus R if R is less than 1, or Sn is equal to A multiplied with R power n minus 1 over R minus 1 if the R is larger than 1. So this means that R is cannot be equal with 1. So next move to the next question.
Hello, Assalamualaikum. So I'll be the one who be discussing about task 5. So let me read the question first. So this question is, a sum of money is deposited into a bank account at the end of each month for 5 years. The account earns monthly interest of 1.75%. What is the compounding factor? So let me tell you what is the compounding factor. Compounding factor is simply nothing else but the growth of about the growth of $1 or $1 depending on what country you live over time. $1 the growth of $1 over time. So the formula that I give is equals to 1 plus R over N power of NT. So the one is actually the $1 or $1, and the R is the annual interest rate. When we talk about annual, is yearly, and the N is the number of periods the interest is compounded per year, and the T is the terms in years. So in the question, the N is going to be each month. So the N is going to be 12, and the T is going to be 5 because T is terms in years, and the money is deposited in 5 years. So, but the difference is about the interest rate. The R is an annual interest rate, but the interest rate given in the text is monthly interest rate. So, if we use an annual interest rate, then we have to over the R with N. But in this case, we don't have to over R with the N because the interest rate given is already a monthly interest rate, not annual. So yeah, as you can see in the slide, the monthly interest rate is 1.75%, and then R is equal to 1.75 over 100, and then we got 0.0175. Okay, that's our R. And then the NT is the N is 12 months, and the terms in years, the T is 5 years. So we multiply 12 months with in 5 years, and then we got 60 months. And then so we copy the formula again without R over N, just R. 1 plus R power of NT. So we substitute our R into the equation. So 1 plus 0.0175 power of NT, which is 60 months. And then we calculate, we simplify, we got 2.8318. So that is our compounding factor for the question in task 5. Thank you. Move on.
Assalamualaikum and good evening. So I will going to present for task 6, which is our last task for SEL. The question is, suppose that a 350 deposit is made at the end of each month in a superannuation funds that earns an interest of 40.4% compounded monthly. Using the formula obtained in task 4, find A, the monthly interest rate. So, as the given, 40.4% is for the percentage interest of compound. So we have to find the value of R, which is 40.4 divide by 100 because it's a percentage, and we have to divide by 12 because 40.4 is uh, annually. So we have to find the monthly. We get R equals 0.012. Next, second question B, the compounding factor. From the task 5, we got the equation for compounding factor is R equal 1 plus R nt, the power of nt. So we just substitute the value of R and n, and we got 1 plus 0.012 power of 12, which is 12 months, and we got 1.154. That's our compounding factor. Next, final question, final task is the final amount in the account after 25 years, which is 300 months. So the given our first term is 350 ringgit, and our R we got 0.012, and N our N is 300 months. So we use the accumulative formula from task 4, which is Sn equal A power multiply with R power of n minus 1 divided by R minus 1. We just substitute the value into the equation, and we got 1,015,651 ringgit and 10 cents. So the amount of the account after 25 years is that value. That's all from me. Thank you.
Right. So for what did we learn from this SAL assignment? Right. So from the task that we have done, we came to a conclusion that arithmetic sequences and geometric sequences can be very useful and applied to all sorts of work. So for example, using arithmetic sequences, we were able to understand the workings of the given encryption function in task 1 and also task 2, and turn it into a description function in order to decrypt the code ciphertext in task 3. And in task 4, 5, and 6, we use the sequences to calculate the amount of money accumulated in the bank account, which can actually be useful in real life. So this goes to show how intensive the usage of sequences can be in our daily life, or can specifically in cryptology and also the finance, right? So I think that's all from us, and thank you so much.